Hello. Can you tell about your product, what you do?
Yeah. Hey everybody, I'm Daniel, one of the two co-founders of Superlinked. What we do is we have an open source framework that helps you turn complex data into vectors. So if you are into vector search, but your data is not just pure text, but you have numbers and timestamps in there, and text and maybe images, then we help you make vector search take those signals into account when you actually do your searches without having to do only filters and re-ranking based on your metadata. We can help you use that metadata as signal in your vectors, in the vectors themselves. So for example, if you have a query like recent news about potatoes, right? The word recent is a reference to a numerical property of the data, right? There will be no part of the news article that says recent. And because with Superlinked you can encode the timestamp when the news article was published into the actual vector, then you can handle a query like recent news about potatoes in one pass through the vector index. And so we have a framework that helps you do that, and then we work with vector databases who handle the actual storage, right? So we work together with vector database providers on making vector search more accessible, easier to use.
Cool. Can you show some demo and how it's all works?
Yeah. I'll show you a quick example. This is actually from my presentation at the Databricks Summit last week. And it's just a quick example of how you would build personalized news search project with Superlinked. The basic concept is that you have your data, right? You have your news articles and users and events. And the news articles, as I mentioned, is not just the text, right? It's not just the content, but maybe there is a moderation score and a like counter and a timestamp when it was published. The user has, maybe during sign up, they give you their interest. And then the events have different types, right? Like clicks and likes and so on. And what Superlinked allows you to do once you define your data like this is you can define your spaces, we call them. These are abstractions over different types of encoders, right? So recency space, for example, helps you encode the creation timestamp of the news article. The popularity, the number space allows you to encode the like counter of your news articles and so on, right? All the way down to text similarity space, which is basically a wrapper over sentence transformers, and it's a way to turn text into vectors. So this is just a simple way to define how you want to encode the different properties of your objects. And then from there, you can create your index, right? And the index combines a bunch of these spaces together, right? It makes a vector that encodes recency and popularity and trustworthiness and the actual text of the news into one big vector. And it also defines how the events affect the vectors in your index. So for example, every time a user clicks on a news article, the vector that represents the news article gets added to the user vector, right? So you build representation of what each user actually likes. And then finally, we have our own query language where you define different parameters of the query. So here we are finding news articles given a text query, and also given 4 different weights for the different signals that we encoded in the vectors. And then we are also doing personalization because we say with vector of the user given a user ID, which takes advantage of the behavioral data-driven user vectors to do personalization. And then finally, you can experiment with Superlinked in a Python notebook, define your index, push some data in, run queries, see how it works. But then when it's time to actually build something useful, we have a server that you control in the same way, but then you say, okay, REST source news, REST source user, which gives you API endpoints you can push the data in. It also gives you API endpoints for your queries, and this is how you define the index. And then you connect to the underlying vector database, and this basically boots up as its own standalone service with a simple command, with Redis and Mongo being the first 2 partners. And then this is a way to execute this index in the real time in a service, but we also have, for example, Apache Spark compiler to help with backfills and batch evals and that kind of stuff. And then finally, if you start that server, You have an endpoint for a query that, all the parameters that we have defined for the query, now you can provide as a part of the input to the API, including the weights, which get applied to the search vector and allow you to bias the search to different, to freshness, to fresh results or trustworthy results and so on. And then last step is, let's say you don't have all of those weights, right? You don't know if the user wants recent news or they don't care about the time aspect. And that's where we are going to launch a feature where you have a natural language query, right, that combines all of these different things, like recent news about crop yields, that you can only provide the query and then the weights are inferred from the query text automatically, and that sort of ties it all together.
Yeah. Cool, thank you.
Thank you so much. All right, have a good one.